Hello students, we are going to start with introduction to complex analysis. So this this topic or this whole subject is based on complex number system. So we all have understood the real number system. So why do we need this complex number system? So we need a complex number system because there are equations whose solution cannot be obtained in real number system. All right, so how do those equations you come across? Okay, so those equations come when you model some real system. For example, you model a real system and you come up with some governing equation, right? Then you try to find the solution to analyze that real system, right? For example, you model a fluid flow based on Navier-Stokes equation, you simplify Navier-Stokes equation, and then you get a equation, final equation, which you want to solve, but you cannot find real solution to that equation. So in that case, complex solutions are obtained, and therefore to interpret those results, to interpret those solutions, you must understand the complex analysis, right? So this whole subject will help you at those times, especially in research, where you have so many equations whose solution cannot be in real system. Okay, so let's just begin with introducing. For example, you all know this very famous equation. Can you have a real solution to this one? No, right? So x can be, its solution is basically I is what? Root of -1. Okay, so this is where the whole complex analysis thing begins. Okay, so let me just tell you something. So how the complex plane looks like. Okay, you have, it's same like Cartesian, but it's just, instead of two real axes, we have one real axis and another one is imaginary axis. Okay, imaginary axis. So you represent a complex number with this x comma y, or what? X plus iy. Okay, so this lecture very short. This video is going to contain only introduction to complex number. I will increase the level equivalent to this subject, this course, introduction to complex analysis. So what is it going to be? So x is going to be on the real axis, right? And y is going to be on imaginary axis, right? So what will be the coordinate of a purely real number? X comma 0. This is also equivalent to some, let's say, real part of z, right? If somebody asks to write like this, okay, what is imaginary then? Sorry, I am part of z. Okay, now couple of things. So this is z, right? You can resemble a complex number with the help of vectors also, right? So what would be minus z? Tell me. Minus z would be taking the mirror image across the origin. This just, it would be what? Minus z. Tell me what is z bar? Okay, so z bar is nothing but mirror image across the real axis. This is going to be z bar. Tell me what is I into z? So I into z is going to be something like this. If this angle is going to be 90 degree. This is just to understand. You can prove it, or you can I would say, yeah, of course you can prove it further in the lecture. So this is going to be what? I into z. All right. So okay, so some of the basic mathematics I just want to revise, which is needed for this course. Okay, so what is it? Yeah, you understand that I told you real part of z, and so addition and subtraction, if there are two complex number x1 plus iy1 and z2 equal to x2 plus iy2, So z1 plus z2 and z1 upon, so you understand z1 plus z2 you might be knowing, so still x1 plus x2 plus I y1 plus y2 I, right? And similarly z1 minus z2. What is z bar? So z bar, like I said here, is just wherever there is a I in the expression, you will put minus I, right? So here x minus iy, and minus z is what? Minus x minus iy, or in terms of coordinate, if you want to represent, minus x comma minus y. So what is z1 upon z2 then? I hope you can see it. So z1 upon z2 will be what? You can just find it out, x1 plus iy1 upon x2 plus iy2. Okay, I'm sorry about the background noise, please ignore it. z1 upon z2, you can just solve it, x1 plus iy1. How do you do it? You just multiply by x2 minus iy2, conjugate of complex conjugate of the denominator. So what would be x2 minus iy2 upon, so you understand, okay, I forgot to tell you, so mod. So what is the mod of this? Is going to be magnitude of any complex number is what? Root of x square plus y square. Okay. So next I'm going to introduce some geometric representation which is important for this course, important to be able to solve further questions. Okay. So this is going to be x2 square plus y2 square. Now you can just multiply the numerator and just couple the real numbers together and imaginary coefficients of I together. So what it would be? x1 x2, right, minus, alright. So x1 x2, and this would be plus y1 y2. I hope you can see there, x2 square plus y2 square plus I times what? It would be y1 x2 minus or plus minus x1 y2, okay, upon, of course, x2 square plus y2 square. Now there are so can you compare two complex numbers, z1 and z2? You cannot compare them, okay. This statement would be incorrect, alright. And very famous that Sri Dhanacharya equation that you calculate, that gives the solution to a quadratic equation, ax square plus bx plus c equal to 0 when the roots will be complex, when d is less than 0, right? And what is d? B square minus 4ac less than 0. Okay, so now when the roots would be complex, there cannot exist a single root, so there is going to be complex conjugate roots. Okay, and what would that be? You can easily find out, right? X equal to minus b plus minus root of this d upon 2a. So since d is negative, there is going to be I, so there would be one plus I and one just complex conjugate of that. Alright. So next important thing is how you understand the distance between two complex number. Let's say z1 is here and z2 is here, right? z1 z2 can be represented as what? x1 comma y1. This is a complex plane, so I hope you understand x2. So as I was saying, in complex analysis, what would be the distance between z2 and z1? So it is going to be z2 minus z1 mod of z2 minus z1. So what is this? Distance between two two points on a complex plane, of course. So this is real axis and this is imaginary axis. Okay, what would it be? So just find it out. z2 is what? x2 plus iy2 minus x1 plus iy1. Alright, so it is what? x2 minus x1 plus I times y2 minus y1. You already know how to take the magnitude of or mod of this thing. What is x2 minus x1 whole square plus y2 minus y1 whole square, right? This is the original formula that you use in Cartesian coordinate as well, right? So this is how you calculate z2 minus z1 or distance between a plane. Okay, so now we will understand polar form of complex number. Okay, so we will understand polar form of a complex number, right? So let's just take a complex number in on a complex plane, right? So which is at angle theta, and then what is this? If this is x comma y, you understand, right? This is going to be x and this is going to be y. All right. So what is x? Tell me. X equal to, okay, so what would be x? X is, and also this distance is r. So x is going to be, you have just assumed this, right? So or distance of z point from the origin is what? R, right? So r cos theta, and what is y? R sin theta, right? Now you understand z is what? X equal to iy, right? So z is equal to what? R. I'm just going to fast forward it. I'll take r common, I sin theta, right? So there is this something called Euler's notation. So Euler's, according to Euler's notation, Euler's or Euler's, whatever you pronounce, that is e to the power I theta is what? Cos theta plus I sin theta. Alright. So z is going to be what? R into e to the power I theta. Okay. Now what is theta? So understanding theta is important, right? So theta is called argument, right? Argument of z. So this theta is not a function because it is going to have many values. So this argument of z can have many values, okay? But what we do is we try to fix this argument value, and if this theta lies from where? Minus theta, so there is inequality and there is equality sign also. So this theta lies from minus pi to pi, okay? So if this is, then theta is known as principal argument, right? And it is denoted by arg of, okay, so theta is equal to argument of z. So when we put this limit, by the way, in some books that you read, there they put theta from 0 to 2 pi. So this is another notation which I don't think you are going to use, and if you do, you have to mention that you have used this limitation, right? Which one you have used. Alright, so this is theta equal to principal argument of z. Now tell me one thing. Alright, so theta is what? Argument of z. Now we are going to use this notation. Now tell me one thing. So what is argument of z1 by z2? Argument of, so argument of z. Okay, before this I want to tell you that, so argument of z in general is equal to principal argument of z plus 2 n pi. Okay. Now what is argument of z1 into z2? It is basically argument of z1 plus argument of z2. So this may be, okay, so this may be true, but if you use principal argument z1 z2, then this will, in general, this is not true. This can be true, but in general this is not true. Okay, so you understand, right? Theta value can have any theta in the interval of 2 and pi. So n can be what? 0, 1, 2, like that. N is an integer. Okay, so I forgot to tell you that how you measure theta. Basically theta you measure from real axis in this direction. Okay, so from real axis and counterclockwise. Okay, then that theta is going to be positive. If it is opposite, then that is going to be negative. So I'll just take an example to prove this thing. Okay, this especially. Okay, so let's take z1 equal to minus 1 plus I and z2 equal to I. So z1 z2 is going to be what? Minus 1 minus I. Okay, then tell me what is principal argument of z1. As you can see, where is going to be minus 1 plus I? Somewhere here. That is what? This is 45, this is 90, so 135, which is what? 3 pi by 4. This lies in the limit of minus pi to pi. Okay, what is argument of z2? It is on this axis, z2, so it is just 90, which is pi by 2. Now tell me what is argument of z1 z2. Okay, so z1 z2 is going to be what? Minus 1 minus I, where it is going to be somewhere here, and it is nothing but minus 135. So okay, so if you're thinking that why I took minus 3 pi by 4, because this is pi, right? Pi plus 45, pi plus pi by 4 is going to breach the limit of principal argument, right? So this is going to be minus 3 pi by 4, and you can easily see 3 pi by 4 plus pi by 2 can never be equal to minus 3 pi by 4. Okay, now so you understand this. But if you are taking this argument, general argument, where this theta can be anything, you can take these values in such a way that this equation satisfies. Okay, so this is it. And okay, so just one last thing for this video. So argument of, what is argument of z1 upon z2? Come on. So what is argument of z1 upon z2? You can just easily calculate. This is going to be r1 upon r2 e to the power I theta 1 minus theta 2. Okay, so this you can easily prove. I'll leave that to you. Thank you so much for watching the video. Do subscribe to the channel, and in the next video I will start from cube root of unity and some geometric representation of the complex numbers. Okay, thank you.